Hello and welcome to the Road to Autonomy. I'm your host, Grayson Brulte. The Road to Autonomy is brought to you in part by Stantec Generation AV. Stantec Generation AV combines some of the most experienced AV experts in the industry with the resources of a global engineering firm. Stantec Generation AV provides education, consulting, assessment, and guidance to any industry interested in autonomous vehicles. Learn more at stantec.com. I'm your host, Grayson Brulte. On today's episode, we're absolutely honored to have Danny Shapiro, Vice President, Automotive NVIDIA. Welcome to the podcast, Danny.
It's great to be here.
It's super exciting to have you here because every individual I talk about runs on NVIDIA. I read about in the papers, this vehicle, that truck, running on NVIDIA. It's really, truly impressive. How are you doing this?
Well, so we've created an open platform. It's an accelerated computing platform for autonomous vehicles. And it's really involved hardware and tons of software that we've been building over the last decade that we're making available to the auto industry. So car makers, robo-taxi companies, trucking companies, and hundreds of startups are now all developing on our technology and creating their applications regardless of the type of vehicle they have or the level of automation they're targeting.
Why did NVIDIA first get into the automotive market?
Well, as you know, transportation is a huge market. But if we go back sort of over the history of NVIDIA, we started as an accelerated computing company. And that's not necessarily the word that people would use to describe us. They think of us as a gaming company. But in fact, gaming was the first really killer app of computing lots of math in a super fast method in a very short period of time. And that's because you had to display three-dimensional graphics, very mathematically, computationally intensive. From there, we expanded into high-performance computing and artificial intelligence. Along the way, we were doing work in consumer electronics and phones and tablets. And that really paved the way for us to get into the car. If you go back a decade or more, electronics inside vehicles were pretty rudimentary, and in fact, lagging well behind what you could pick up in a consumer electronic device. And so we saw an opportunity and started working with automakers to bring the innovations from Silicon Valley into the dashboard. And so from those early days of infotainment, and touch screens, and digital clusters, rear seat entertainment, we expanded into areas where you needed more computing, and that was sensor processing for today's and tomorrow's modern automated and autonomous vehicles.
Are you referencing 1999 when NVIDIA invented the GPU? Is that where this whole movement really started because the compute power was now being created and developed?
Yeah, that's part of it. I think the GPU is a graphics processing unit, and it was designed to overcome performance bottlenecks of the CPU, which is a serial processor, meaning it executes its code in sequence. The GPU is highly parallel and can process a lot more computation in just a fraction of the time of a CPU. And so you think of it as lanes on a highway where a CPU maybe would be a dual core or a quad core. It would have 2 lanes or 4 lanes for data to travel. The GPU has thousands of lanes. So a highway with 1,000 lanes is going to be able to accommodate a lot more traffic. And so those first applications of the GPU were doing 3D computer graphics for the gaming industry, for Hollywood and television visual effects, and for things like medical imaging or computer-aided design. And from that, we've developed a lot of additional applications that will run on the GPU. And a big part of that is now artificial intelligence. So training AIs to be able to recognize objects, to do speech recognition, to do synthetic voices. So when you talk to Siri or Alexa, there's NVIDIA GPUs in the back ends and the data centers that are using AI to figure out what you're saying and then come back with the appropriate responses. So in many cases, GPUs are now being used for non-graphics applications. Inside the vehicle now, we use our GPUs to analyze the camera data or radar or LiDAR data coming in at many times a second and discerning what is around the vehicle. Is it another car? Is it a truck? Is it a pedestrian? What are the signs? What do the traffic lights look like? All of that requires a massive amount of processing in just a fraction of a second.
You mentioned gaming as the first killer app. Is autonomy one of the next big major killer apps?
I think so. I mean, we're doing a lot of work in this space, but it's not, a quick return. As we all know, there's billions of cars and vehicles on the road, and it's going to take a long time for that car park to turn over. But we're still not there yet in terms of having fully autonomous vehicles. There's a lot of work to be done. So it absolutely is an enormous market. We're seeing a lot of growth now, but there's a huge amount of upside moving forward.
There's definitely a ton of upside. You have 370 automakers, tier one suppliers, developers, and researchers as partners. It's a clear indication to me that the market's all in on NVIDIA. When you look at this, and you mentioned speech recognition with GPUs, I think that's really interesting. And for common sense, is that for if say, hey Siri, take me to Publix, or hey Siri, take me to the movie theaters, where it recognizes that, okay, Grayson, you'd like to go to the AMC theater, or you'd like to go to the Publix on Dixie. Is that really with a GPU to make it more of a conversational, or is that say that again, where the GPU makes it simpler and easier to understand?
Absolutely. I mean, if we look at that one topic, speech is very complex. You have many different languages, you have different accents, you have the same word that can mean different things. So the context matters. So a lot of R&D has been and is still going into improving speech recognition. Many things still require you to go to the cloud because of the amount of computation. So when you use your phone and even ask what time is it, the phone knows what time it is. It still goes to the cloud to decode your voice. And so what we're doing is working on bringing that to the edge, bringing that to the local device or to the car. So you don't have to go to the cloud for everything. So that would reduce latency, make it more interactive. And then you do go to the cloud when you have to do the search. So if you're looking for that restaurant, the car doesn't know that restaurant. You need to go to a larger database or checking the weather in Florida or whatever it may be. So that real-time data. But from a speech processing, the recognition, the natural language processing, and that dynamic, we want to bring to the vehicle. So you could say, it's warm. And the car would respond, do you want me to turn on the AC or roll down your window? And you can say, I'll roll down the window. But also the car will be able to recognize, was it the driver or the passenger speaking? And so that's a multimodal approach where we're using AI on the voice, but also with a camera inside that can monitor the occupants, and it can read lips and determine who was talking. So it would roll down the appropriate window based on who was speaking.
You're going to make it fun to drive.
I think the number one focus is safety, right? We're using this technology to improve the safety of our roads, to increase efficiency, reduce congestion. But at the same time, there's a lot of convenience features that we can bring to the vehicle. And once we do have autonomous vehicles, we can totally change the kind of interaction that people have with each other or with technology while the car is driving.
Are you describing the MBUX hyperscreen that's in the new Mercedes EQS? Because looking at that says, okay, this is truly the future. It's running on NVIDIA chips. Is that the clearest, best example before we achieve autonomy of what can be done in a vehicle?
Yeah, I think that's one great example. And we've been working with Mercedes-Benz for years on a number of different initiatives, but it's a beautiful design exterior, beautiful design interior. And you're right, you have that pillar-to-pillar series of screens that are providing information for drivers, for passengers, using voice, using touch, and really focusing on delivering the right information given the context and given who is in front of those particular screens as well. And so there's a lot you can do in terms of anticipating, in terms of understanding the routines of the driver, and certain patterns. And so these systems are designed to get smarter and smarter the more they're used.
If you look at routines today, it's very common. You have seat memory 1, 2, 3. So I have seat memory 1. My wife has seat memory 2. In the future, using the MBUX for an example, will that automatically know, hi, Grayson's in the car. Hi, Grayson's wife is in the car, and automatically preset to the settings my wife wants or the settings that I want running on your technology?
Yeah, absolutely. As you start to introduce cameras inside the vehicle or other sensors, that will be able to detect who is inside. And so there's those convenience features in terms of all your presets, your mirrors, your seats, but even sometimes your driving preferences, right? There's vehicles now you can adjust the tightness of the steering or the rate of acceleration or other handling aspect. And so those kinds of things absolutely can just be done by facial recognition. Adjusting a lot of things inside the car can happen through voice recognition. So again, simplifying the interface. I think we'll see additional features outside the vehicle as well. So cameras are there. They can detect you walking up and through facial recognition, just unlock the car. Or maybe it sees that your hands are full carrying groceries and automatically open the trunk. So we'll be able to introduce new apps, if you will, or new features to the vehicle through software updates. So once all the hardware is on board, it's just software that is able to unlock new features.
I wouldn't necessarily call it features. I would call it common sense. If you're at the grocery store and you're carrying a case of water, it's heavy. You want to put it in the car. You don't want to bumble to find your key. You're going to create so much convenience and value for that end consumer. They're going to flat out say it's awesome. Yes, I want that upgrade when they order their vehicle. Technology is enabling all these wonderfully awesome experiences on human-driven vehicles. What happens when we fast forward into the future at some point? I'm not going to put a date on it, to the future, when autonomous vehicles are running in certain ODDs, environments around the world. What type of experiences will NVIDIA's technology unlock? Will we start to see some really cool augmented reality combined with the AI to have these completely immersive experiences?
Yeah, it's a great question, and it's wide open. There's a lot of research going on. There's some really cool startups doing work in this space, but you're right, the car transforms into a new type of vehicle. It's a mobile office, it's a mobile playroom or mobile theater, a mobile hotel room, but you'll have the capability through high-speed bandwidth, 5G, to get work done, to do video conferences, to record podcasts like this, to watching movies, to whatever it is you want, and playing games. I think there'll be a lot of gameplay. There's a really cool company called HoloRide that is doing virtual reality that's synchronized with the movements of the vehicle. So they're tapped into the IMU. So one of the often concerns or complaints about VR is that kind of messes with your brain. And if your body's moving one way, but the scene's moving another way, it can make you sick. But integrating the motion of the vehicle with what's happening in virtual reality can be a really amazing experience. So I think we'll see all kinds of new applications for entertainment, but also more surfaces in the vehicle could become screens. The windshield could be your movie theater screen, or the side windows could have embedded LCDs. And so you can kind of go into this holodeck kind of environment where you're transformed immediately to another location.
I'm going to take you to a planet far, far away. You stumbled into my favorite topic, experiences. You combine VR with entertainment, games, hotels, and autonomous vehicles. You've got the next Star Wars attraction for Disney World.
We actually, another part of our company does a lot of work with Disney Imagineering. And so, yeah, I think you might be onto something there.
I think I'm onto something. There was a Disney executive who will remain, for privacy reasons, I won't say it, read me the Riot Act over when I gave this vision, and I'll give you the same vision as this person read me the Riot Act, is I believe in the future. So we saw the announcement this week. Disney announced the all-inclusive experience for Star Wars. It's an absolutely brilliant concept. You're going to go and experience Star Wars in this immersive experience. You're going to meet Chewbacca and Princess Leia and all the various different Star Wars characters. And so it's really great. It's really interesting. So if you look at the fine print and me reading all sorts of random stuff, Disney says, okay, you arrive between 11 a.m. and 1 p.m. Eastern, and then they're going to put you on a quote-unquote spaceship to take you into outer space. And you're going to have this whole immersive experience for your 2 days. But now let's go back this forward. So your experience, if you talk to individuals that work in the hospitality world or work in hotels or resorts in general, they say to me, they go, Grayson, the experience does not start the minute you arrive in our hotel or on our property or resort. It starts the minute that you leave your house to get on the airplane. What we want to control is the minute you land at the destination airport till you get there. So Disney being Disney, Florida having the best laws in the books for autonomous vehicles. Imagine this. You have a level 4 autonomous vehicle powered by NVIDIA technology, picking an individual up at the MCO airport, which has got a really cute nickname. It's called Mickey's Corporate Office. I've learned that from the travel agents because all the amount of money that goes in there. It autonomously drives you there and looks like you're going to the Star Wars experience. Now, suddenly, it looks like instead of the car driving, it's flying. You start layering on the experiences. Okay, well, you had a long flight. And Danny, you're in the Bay Area. You flew from San Francisco to MCO, about 6 hours, 6:10, depending on the winds. Oh, kids want a Chewbacca doll. Okay, that's $39.99. Okay, Daddy wants a beer. That's $18.99. Starts billing you all these different experiences. That's something that's going to become really impressive. That's something that your technology is going to allow it there. And if you have another child in the vehicle, they might want to play the Star Wars game. That's going to run on your technology. you're the glue that's going to hold this all together. It's going to be really interesting to see. Have you looked into any of these experiences and how NVIDIA's technology will enable these completely immersive experiences?
Yeah, if you look at what we're doing, it's a core technology company that has many vertical industries that are, just growing. Gaming is enormous and still is growing. And so we're doing a lot of work there with respect to PC gaming, mobile gaming, cloud gaming, and virtual and augmented reality. And that same core technology is what's powering AI and powering autonomous vehicles. So yeah, we see a lot of synergy between these things. We have created something called Omniverse, which is being used in everything from entertainment to autonomous vehicle simulations to factory automation, which is basically the creation of a digital twin, being able to create these virtual environments and be able to run all kinds of simulations and tests. So we can actually train autonomous vehicles or train robots in the virtual environment, which is a much safer way of doing it than in the real world. And so we're truly creating this digital twin. So the roadways are mapped, the environments are built and designed to be photoreal. And so then we can actually simulate the software that's running in the vehicle, but do that in the data center. So the same technology can then also be leveraged once we've built this digital twin. That becomes the basis for any kind of entertainment as well. So you can have these virtual environments that we all can participate in and interact with and have experiences in them.
Are you referencing the LinkedIn post that you wrote on March 25th, 2021, titled How AI is Changing the Way the World Moves, where you stated, building safe autonomous vehicles is one of the most complex computing challenges today. Advanced sensors surrounding the car generate enormous amounts of data that must be processed in a fraction of a second. Vehicles must be trained, tested, and validated on millions of potential driving scenarios. Developing this technology requires high-performance solutions that extend end-to-end. Is that what you were explaining?
Yeah, I think that's part of it for autonomous vehicles. Essentially, there's a lot more than just having sensor processing in the vehicle. Before we even get to that point, we need to collect a massive amount of data and train deep neural networks. These are basically the AI algorithms that can detect pedestrians or read street signs or tell what color the lights are. So all these things that we take for granted as humans need a massive amount of data and training for the computer to be able to achieve superhuman results and sensing and then reacting and then planning. So the work we do starts in the data center with supercomputing for training deep neural networks. But then this concept of the digital twin is used very heavily to test and validate. And so we can simulate all types of scenarios, all types of traffic conditions, day, night, all different kinds of weather, and repeat them over and over and develop the software to ensure it's safe. But you don't want to be out on the roads testing, does the car detect a dog running across the street or a child chasing a ball at night, right? That's just too dangerous to be able to test that. And so using simulation, running the actual hardware, the actual software that ultimately will be in the car, but it's running in a simulated environment, lets us develop and be able to do much more than we ever could in the real world.
Simulation plays a key role in the future of autonomy. Casser and Peter, the co-founders of Apply, came on an earlier podcast and, in my opinion, gave a masterclass on simulation and all the really good positive things it has for a safety perspective. And staying on that line, NVIDIA recently announced the acquisition of DeepMap. Really smart, James and Mark, two of the most incredible, smartest individuals there are. Both have been on the podcast, by the way. Will that be integrated into that simulation? Will you take that incredible mapping data, and I don't want to misquote Mark, but I forget the exact precision that those maps have. Will you put that into the simulation, into the data centers too?
I think that's definitely part of it. I mean, we're super excited about DeepMap joining us. And there's a lot of great technology. We've been working with them for many, many years. And it was just a great logical step for the companies to come together. So their technology for developing the maps, for keeping them updated, and the extensive team they have around the world to build maps. You need maps everywhere you want to drive. And so whether it's in Europe or America or China, right, we need teams there that are responsible for creating those products and building those maps. And so, yeah, we'll be using that in the development of the autonomous systems. And absolutely, those maps can be brought into our Drive Sim software and used to test and validate all different types of traffic patterns and behaviors. Really, a big part of this is figuring out how do other cars, other trucks, pedestrians, bikes behave around you. And so the biggest challenge for autonomy is predicting what the unpredictable humans will do. I think, if all the cars, all of a sudden we flipped a switch, everything was autonomous, it would make it really easy because autonomous cars will be very predictable and they'll be able to communicate as well. But when we have this hybrid for the next several decades, even when we have the unpredictability of humans on the road, we need to really be able to anticipate that. And so there's a lot of work going on in training for anticipating behaviors. For example, you see a pedestrian on the side of the street waiting to cross. If they're on their cell phone, it's pretty clear they're not paying attention. They're distracted and they may step out into traffic. Whereas you have a pedestrian that is making eye contact and waiting or push the button, their behavior very likely could be different. And so the autonomous car needs to be able to anticipate and react to those two different types of pedestrians. So there's still a lot of work going into modeling all that. And through simulation, we can train the vehicle to be smarter.
The hybrid years where you have human-driven vehicles and autonomous vehicles are going to be point-blank very challenging years because you can't predict the behavior. Do you look at the behavior of certain level 2 and level 3 systems, how some of them aren't necessarily behaving the way they're supposed to? Do you put that into the modeling when you start to build this out?
I think there's a long way to go on all these systems. Different technologies are going to improve that. I mean, there's been a lot of talk about V2V communication. So if one vehicle can communicate what it's doing to another vehicle, that's great. That's basically another sensor input, and that sort of removes some of that uncertainty. The problem is it doesn't exist and it's not ubiquitous. It really needs to be ubiquitous for it to work. So that's something that over time can help. But in terms of all these different systems, once we have a software-defined car, meaning there's a powerful computer inside, it's able to get over-the-air updates, and all these systems are tied into this centralized computer, these software updates will continue to improve the performance. So it's not like the capabilities are locked when you purchase the car and drive off from the showroom, but those cars get better and better. And I think that's the biggest difference we're seeing. Companies like Mercedes-Benz that we just announced with aren't putting this technology in a few of their cars, the high-end cars, or make it optional. The technology we're developing for Mercedes-Benz will go in every single vehicle. It's standard. And then the customers will have the ability to get software updates to add new features and capabilities throughout the life of the vehicle. So even if they don't buy something at the time of purchase, they'll always be able to upgrade that car later. But that car is also sensing always. So it's running the software regardless of whether it's in autonomous mode. And so it can be learning, it can be uploading data to the cloud, it can be part of the fleet that's teaching all the cars to get smarter and smarter. And so I think that's what's really going to change is as we see more car makers, there's a number we're working with in China. We'll be making more announcements soon with additional automakers that are adopting our technology and putting it in every single vehicle. And that's really how we're going to improve these systems dramatically. It's not making it optional, but at the core of every car in their fleet.
Updates for vehicles is one of the most consumer-friendly decisions automakers could make. It has a tremendous benefit for the consumer. It gives the auto companies the ability to generate more revenue, and you have a happy customer because you can constantly add new features to the vehicle if that individual chooses to add those new features. I wish my car had over-the-air updates, but they decide they don't want to, even though I pay for the cellular. Can't update it, but great car, but hopefully they'll get there. So you have all these incredible technologies going into the vehicle. You mentioned powerful computers in these vehicles. The world is clearly shifting to electrification, to electric mobility. Do you see an impact on the range when you put all this incredible compute power in these vehicles?
The computing does consume energy. I think we've been working for a long time on how do you create the most energy efficient systems. And our company and our engineering teams probably more than a decade ago went through a huge re-architecture to focus on that. And part of that was initially driven by mobile computing for laptops, but also mobile phones and tablets. And like I said, the automotive work we're doing is really an offshoot of what we were doing in that consumer electronics space initially. The performance of our products was much greater than your typical laptop or phone even needed. And so automotive was a great home for us with these true supercomputers that are sometimes hundreds of times more powerful than a laptop computer in terms of their performance, but extremely energy efficient. And that's why we've been so successful in this automotive space. So we're continually working on reducing that energy consumption. But you're right, there's a lot of things that are getting added to these vehicles, whether it's the cameras, the radars, LiDARs, data recording. All of these things do consume energy, and it does have an impact on the range. But we're also seeing battery technology evolve and become more efficient.
Is the automotive team interacting in a cross-functional manner with the team that's designing laptops and mobile phones to share and learn things? Because it seems to me, looking at NVIDIA from the outside, there's all these incredible synergies inside the company that can, if everybody talks together, it's something really special could happen.
You're absolutely right. There's one centralized engineering organization. And of course, then there's specializations with that, but all the engineering for hardware rolls up. Same thing on the software side. There's a lot of benefits from standardizing a lot of our software stack. If you look at something like autonomous driving, where we're taking images from front-facing cameras and trying to detect pedestrians, our healthcare group and the work they're doing in medical imaging and cancer research leverages a lot of that same technology, because if you do a scan, an MRI, an X-ray, you're looking for cancer cells. It's not that different a process from what we're doing with pedestrian detection. And so absolutely, there's a huge amount of cross-functional work that goes on, of sharing. We have internal conferences where engineers present their work, their developments. Our research guys present within the engineering circles to share these learnings. So it's a great company culture. It's very entrepreneurial inside the company. We're now 20,000 people. It still feels like a startup. We have really groups of startups all working together.
Why was the decision made for the central engineering of software? Was that made on day one when the company was founded, or did that emerge as the company expanded?
No. I mean, initially we just had a single product line, but as the company evolved and we grew into having different lines for PCs, for laptops, for servers, for mobile devices, we started to have different architectures. And we realized that we needed to unify that, partly because the company wasn't that big. If you look at other computing companies that have the revenues and market cap as us, they have sometimes 5 or 10 times the number of employees. And that tends to be because there's all these different silos. And so we've really designed the company to be this horizontal engineering organization that supports all these really amazing different verticals, from transportation to media and entertainment to healthcare. It seems like crazy different types of companies all under one roof. But at the end of the day, the core technology is focused on a single thing.
Danny, I remember years and years ago, you and I would bump into each other at conferences and we'd talk. And at that time, it was robotaxis, that everybody was talking about these conferences that we would run into. And then there was always to the side, there was always kind of, autonomous trucking was not really popular. Peloton was still in business at that time. And now autonomous trucking is at the forefront of this, and robotaxis, certain individuals scratching their heads on that business. And NVIDIA has very quietly built an incredible ecosystem in autonomous trucking. The company has 15 truck partners currently working on autonomous trucking. How were you able to build that incredible trucking business at the same time you're building the robotaxi business? Because looking at this from an outside perspective, you made the absolutely brilliant right decision to go double and triple down on an autonomous trucking, as that seems to be the first path to commercialization.
I think it's a good observation. From our standpoint, it wasn't really any kind of a shift. I think our platform being open, being modular, working with different sensor companies, different mapping companies, lets us adapt it very quickly. And the challenges of creating a robotaxi versus an autonomous truck can be different, but the underlying core technology is the same, right? You have to sense the environment. Mapping plays a role in understanding where you are, where the vehicle is, being able to make driving decisions and then actuate the vehicle. And so, yes, the vehicle is a lot bigger. You may have different types of sensors, those sensors located in different places. But we simultaneously have been working with robotaxi companies, with passenger vehicle companies, with trucking companies, with off-road companies in agriculture or mining or construction. So it's basically what we've seen is this migration of where it feels more comfortable to deploy these vehicles. And so on the highways is certainly an easier problem to solve than dense urban areas. And that's where we're seeing long haul trucking, and companies like Too Simple that we've been working with for many years are making great inroads, delivering packages. And everything from a whole variety of different truck makers like Embark, we just announced with Plus in Asia. So many of these companies are doing great work. The challenge they are trying to solve is the same, and they need a massive amount of compute. And really, they can go nowhere else today to get the automotive grade, high performance computing, energy efficiency, and small form factor other than the NVIDIA Drive platform. And so by focusing on solving these challenges for the transportation industry has allowed us to then serve all these different entities.
It's brilliant. From an investor standpoint, absolutely brilliant. You have all the leading companies in autonomous trucking are running on the NVIDIA Drive platform. You have individuals, Chuck Price, the chief product officer, Too Simple, who's been on the podcast in the past publicly stating about NVIDIA, our technology developed in partnership with the NVIDIA is ready to go to production with Navistar. This is a significant turning point for the industry. Is that due to the breakthroughs that your company has had with the drive technology that's allowing Too Simple to build the factory-built trucks with Navistar? Is that the incredible power that is in those chips?
I think if you look at what NVIDIA as a company tries to do, we look at solving the world's most challenging problems and developing computing solutions to do that, hardware and software. But a lot of times we're not the one who's building the final application. If you look at in the gaming world, we're not writing the games, but we provide the platform, the tools for the game developers to create their products. And so in autonomous vehicle space, it's not that different. We're not building the trucks, we're not building the cars, but we're helping our customers do their life's work and create amazing products. So whether it's a Mercedes or a Volvo or a Too Simple or a robo-taxi company like Zoox, our technology is the platform that they can build their amazing vehicles on.
You're providing the platform for enable the future of autonomy. There's no doubt about it. My big question is, how can you keep up as when robo-taxis start to commercialize, Amazon turns on the Zoox commercialization, Too Simple has thousands of trucks, Embark has thousands of trucks. How can you keep up with this unprecedented demand that's going to sweep the industry and put pressure on your company?
I think you raised an interesting point, but what we've done is developed these systems to be scalable, both in the cloud and the vehicle. And so you're right, it's not about creating a car or a truck, but it's how do you maintain this fleet? And so this fleet is constantly gathering data. The data center side is enormous. That's another part of our company that's doing extremely well, is using AI in the cloud. And so we work with Google and with Microsoft and with Amazon and all the big cloud providers. That's going to be another huge growth area that the public isn't even aware of or sees. But the technology that goes into developing the AI and maintaining the AI and improving the AI is going to be a huge investment area moving forward as well.
You've mentioned data center several times, and now you're in trouble because you piqued my interest. So you mentioned the relationship with Google Cloud. Is NVIDIA selling this to autonomous trucking companies, like leasing time on your compute platform? Or are you working with other third-party platforms for that?
Oh, absolutely. So you talked about conferences. They've all been virtual, and eventually we'll get back to real in-person events. But a lot of the sessions at our GTC and others would be a company like Amazon, AWS, talking about their cloud solutions. You're exactly right, where these autonomous vehicle startups or even some of the OEMs can lease time for their development, for running their sim. But in many cases, the larger companies are building their own data centers as well. It does require a massive amount of compute, and getting started is great with these partners, but sometimes the choice is to build their own.
Either way, the company's well-positioned. Earlier, you mentioned ag. The ag space is starting to become really, really interesting. John Deere acquired a couple years ago Blue River Technologies, and they recently acquired Bear Flag Robotics. Do you see that from an NVIDIA standpoint becoming a growth market for you as automation starts to work its way onto farms and you have extremely well-established international corporations such as John Deere doubling and tripling down on this technology?
Yeah, we do. And we work with these companies already. That's one of the advantages we see when we have a number of startups that are developing on NVIDIA. Sometimes that's the way that the larger companies end up adopting our technology because they're not moving as fast. And we have a program called Inception that actually has well over 8,000 startups that are building their product lines on NVIDIA. But, so a company like Zoox, a startup, gets bought by Amazon, a massive corporation, and that helps them jumpstart, but then they're developing on our technology. We have customers like Uber and Aurora. Well, they've now merged. And so the benefit of that is that they were both leveraging NVIDIA drive technologies. It's not like they have two totally different architectures that they have to merge. They have this common language among their engineering team that they'll see synergies from. Again, another advantage of our vast ecosystem and the number of startups that we're working with enables these kinds of mergers and acquisitions to really let them hit the ground running because the technology is compatible.
From robotaxis to trucking to ag to data centers, what are your thoughts on the future of autonomy and what role do you expect NVIDIA to play in that future?
I think we're still really just getting started, right? This is a very long-term play. I think we all expected 5 years ago that we'd be in a different place right now. And there was sort of an awakening a year or two ago when everyone realized, 2020 is coming and we're not sleeping behind the wheel. No, we're still driving. And it's proven to be a much greater challenge than anyone really thought it would be. We're still dedicated to it. We're working on deals for 2025 now and have a roadmap going to 2030 and beyond. And that's really, transportation has always been this very long-term planning horizon. And so you can't hurry safety. So we're focused on ensuring that the technology is rolled out when it's safe. We have a variety of different use cases. We have different levels of autonomy that we support. But again, our strategy is to have this upgradable approach so that our customers can be investing and developing in technologies and putting them in vehicles, and then we can continue to test and evolve the software and roll it out publicly once it's deemed safe or once the laws are in place to properly support it.
An upgradable approach is a smart approach. An upgradable approach is a wise approach. And Danny, as we look up to wrap up this incredible conversation where I learned a ton about NVIDIA, what would you like our listeners to take away with them?
I think the future of transportation is really going to be awesome. I think there's some patience that we'll have to endure. But today, again, there's a lot of really cool innovation and a lot of nice safety features that are coming out in vehicles in the short term. And so for me, I've been driving a car that can drive itself. I still have to pay attention, but it does a great job of doing it. And the car gets better and better with each software update. It's kind of creates a joy to drive. And I don't think I could ever go back and buy a car that wasn't connected and got over-the-air updates like you were just discussing. And so once you have a feature, once you have a capability in a car, it's really hard to go back. And I think people have experienced that sometimes, if you had a backup camera or maybe there's blind spot monitoring or adaptive cruise control, whatever the feature is, once you get used to it and you realize it's not just makes driving more enjoyable, but there's a clear safety advantage, it really does not make sense to ever give that up. And so I think we'll just see more and more people experiencing the joys of these types of cars. And it will be an evolution to the point where you finally can unplug from the driving experience and plug into your game or entertainment as you cruise from San Francisco to Los Angeles. And the car will truly drive itself. So I know that's coming, and I'm really looking forward to that as well.
That's coming. I'm happy you point out the safety features because lane keep assist, the backup camera, they've all have positive impacts and they've saved countless lives across the world. They're only going to get better at that technology. I'm a big fan of lane keep assist. We wanted to keep getting better. And thanks for pointing out over-the-air updates. I feel like a dinosaur now. Your vehicle's got over-the-air updates and mine, they still won't do it. So Danny, thank you so much for coming on the Road to Autonomy today because the future is bright, the future is autonomous, and the future is NVIDIA. And as Danny says, the future of transportation will be awesome. So Danny, thank you so much.
Grayson, great to talk to you as always.
Well, thank you so much. Thank you for listening to the Road to Autonomy podcast. If you've enjoyed listening, please rate, review, and subscribe on your favorite podcast platform. Want to get in touch? Follow us on Twitter @Road to Autonomy or email podcast@BREAUTO.com. BRULTECO.com. The Road to Autonomy is produced by Brulte and Company. The views and opinions expressed on the Road to Autonomy podcast do not necessarily reflect the views and opinions of Brulte and Company. The content discussed on this podcast is for informational purposes only and should not be taken as legal, tax, investment, or business advice.